Today we're going to be taking a look at FRQs for this topic. On the AP exam there are 4 FRQs total. There are always 4 FRQs on this AP exam. Each FRQ is worth 6 points. Modeling a non-periodic context is always number 2 of the 4. Number 3 is modeling in a periodic context. That'll be using trig. Okay? So there are similarities to these, okay? But in general, of these 6 points, on each FRQ, of the 6 points, usually there are a couple of easy points to be had, a couple of like mid-range points, and a couple of hard. Okay? Oops. A couple of easy, a couple of mid, a couple of hard. That's just the way these are. All right. These do have some similarities for this FRQ, for topic 2 here. For this one, there are similarities. Part A is always to have you find the constants of an equation that you're given. Okay? Always. Part B, from what I've seen, Part B is almost always using average rate of change of the function. And then Part C is something different. It could be just a variety of things. So read through this, but we're going to go ahead and go to an example. We're going to do 2 of these, and then you have 3 to do for homework. Okay. Students who completed a class participated in a year-long study to see how much content from the class they retained over the following year. At the end of the class, students completed an initial test to determine the group's content knowledge. At that time, at time 0, the group of students got a score of 75 out of 100 points. For the next 12 months, the group was evaluated at the end of each month to track their retention of the content. At 3 months, the group's score was 70.84. Okay. The group's score can be modeled by function R, where R is the score in points for month T. T is the number of months since the initial test. Okay, Part A. I already know what Part A is going to be. It's going to be finding A and B. Using the data, find A and B. It always is. Part 1 of Part A is use the given data to write 2 equations that can be used to find the values for A and B. Part 2 is to find the values of A and B. These are always with a calculator. Topic 2 is always with a calculator, and so they want us to write it as a decimal approximation. So I'm going to write 2 equations. One of them is going to have time 0, using the 75 for the score, and one of them is going to have time 3, using the 70.84 for the score. So down here, and you guys will have a separate booklet to write your answers in. I don't have a separate booklet for you. I do have a separate box for you. Okay? So there's that. So Part I of Part A is just to write the 2 equations. Okay? So the first one's going to have time 0. So I'm going to have A plus B ln of 0 plus 1 is equal to that initial score of 75. The second equation is A plus B ln of time 3, and that score was 70.84. Okay? Now for the second part of Part A, we're going to actually find A and B. So I'm going to go to my first equation because I see ln of 1 here. And ln of 1 is 0, isn't it? So that's going to give me A is equal to 75. You don't have to show the work to get there. it's clear what we did to get there. Now for the second equation, I'm putting 75 in for A, like that. I'm going to subtract 75 from both sides. And I have a calculator. I'm going to let my calculator do that. And then I'm going to divide both sides by the ln of 4. And that will give me my decimal approximation. Okay, so let's go to our calculator, type that in. Excuse me. I'm going to use parentheses around my entire numerator. And I get -3 points, so we need to give at least 3 values after the decimal place. I almost always give 4, and that'll work for me. Okay, so that's B. Now, this is what I write down. But when I'm going to need to be using B throughout the rest of the problem, right? So I want to keep the entire value in for B. So what I'm going to do right now is I'm going to store, using the store button down here, I'm going to store this decimal in for B. So I hit that store button, it takes the previous answer and it stores it in for whatever you say. To get B, that's this alpha right there, so alpha B, enter. And now anytime I use B, my calculator knows B is -3.000805685, and probably some more decimals beyond this that are not being displayed. Okay? By the way, instead of doing it with parentheses around the 70.84 minus 75, we could have gone and gotten the fraction template. It's under F1, fraction template, and done it like that. 70.84 minus 75 on top, ln of 4 on the bottom, and we still would have gotten that same value. Okay? So part A is done. Part A is the easy part of this problem. Let's go to part B. But part A already got me 2 points. That was 2 points. So on your actual test, you will be told exactly where to write that answer. There will be a box just for part A and a box just for part B. So I didn't do that, but you can box this off if you want. So here comes part B, and it'll tell you, write your answer to part B here. It'll tell you that. Okay, part B. Use the given data to find the average rate of change of the scores in points per month from 0 to 3. 0 to 3 months. Express your answer as a decimal approximation. Show the computations that lead to your answer. So part B, average rate of change. As soon as I see that, I think change in and change in. Change in over change in. Our function is R. Our independent variable is T. So that's what I'm thinking of. So I need R, this is part 1 of part B, I need R at time 3 minus R at time 0 divided by 3 minus 0, and that was 70.84 minus 75 over 3. Okay, back to our calculator because we need to get a decimal approximation. Okay, you can use the fraction template or you can use parentheses around the numerator, either one. I almost always just use parentheses, but you're welcome to use the fraction template if you prefer. Of course, you get the same answer regardless. Okay, so this is -1.3866. You always have to give at least 3 digits, 3 numbers after the decimal point. Okay, so that's the average rate of change, part I. another point. We earned another point for that. Part 2. Interpret the meaning of your answer from Part 1 in the context of the problem. What does this mean? What does that mean? Okay. That means that from 0 to 3 months, the score was decreasing by this amount per month. From 0 to 3 months, the score was decreasing an average of 1.3866 points per month. That's the meaning of that average rate of change. Excuse me. Okay, so far I feel pretty darn good. I'm expecting it to get harder though, because that's what they do. Part 3. Consider the average rates of change of R from 3 to P months, where P is bigger than 3. Are these average rates of change less than or greater than the average rate of change from 0 to 3 months found in I? Well, you guys, we are using almost always in this part. I will tell you somewhere here in this problem, somewhere you're going to be examining the graph of your function. Okay, so here it is. We are going to look at the graph of R. Okay, and it's stored into my, well, is it stored into my one? Did I store it in for Y1? No, I didn't. I didn't store it in, and I really don't have to store it in because I know what log graphs look like. Don't we know what log graphs look like? What do log graphs look like? They look like that, don't they? Every log graph with a positive coefficient is going to look like that, right? Time is positive, the coefficient is positive. This is going to be the graph. It's going to be the general shape of the graph, right? Oh, you know what? B isn't positive, is it? B is negative. So what's it going to look like with a negative B? It's not going to look like this. What's it going to look like? It's going to look like that. Of course, the scores are not going to be going up, are they? The scores are going to be going down. You know what? Let's just go in graph B. Let's go graph R. So A, which was, what was A? A was 75. 75 plus B, which is negative, ln of t plus 1. That's what they told us it was, right? Let's go graph that. Let's see. What is the highest score possible? It's not going to get any better than 75, right? So the highest score possible is at 75. I might make it a 76 just to see a little bit above there. Okay? What's the lowest score going to be? Maybe 0? I don't know. Will they ever get down to 0? Will they lose everything that they ever learned? I don't know. We'll do 70. We'll do 0 down there. And for the x-min, I'm going to put -1 just to see a little bit to the left of the y-axis. And then for the x-max, this is the number of months, isn't it? So they say that we're going to 12 months. Oops. They say we're going to 12 months, so I think I'm just going to go there. Okay, let's do that. Oops, what did I do? Quit. What did I do? Oh, sorry about that. 0 to 76. There we go. Oh. Well, this model is showing that we don't get anywhere close to 0, do we? I think I'm going to make that instead of going down to 0, I think I'm going to make it, it looks like it doesn't get even close to that. Okay, that's better. Okay, so we're starting at 75, and we're going down from there. After 3 months, we're at that 70.84. So after 3 months, we're at 70.84, right? Okay. Now we used, let's see. Okay. We found the average rate of change from time 0 to time 3. We found that average rate of change, right? We found the slope of that line. That's the slope of that secant line. Okay? Part 3 is asking, consider now the average rates of change from 3 to p, where p is bigger than 3. So here was the average rate of change from 0 to 3. This would be the average rate of change from 0 to p. P is bigger than 3. Are these average rates of change less than or greater than the average rate of change from 0 to 3? Average rate of change 0 to 3. Average rate of change 0 to p. This was a negative 3 point something. This will not be negative 3. It'll be bigger than negative 3. It's still going to be negative, but less steep, right? It's getting bigger. Okay? So I'm going to write for my response for part 3 of part B down here. I'm going to say that the average rate of change from time 3 to time p is greater than the average rate of change from time 0 to time 3. Since, we need to give a reason. They said to give a reason. Since the graph of R is increasing, it is decreasing, and concave up. This part is almost always going to have you use the shape of the graph of your model. Okay? Almost always. Okay. Part C. The leaders of the study decide to use Model R to make predictions about the group's score beyond 12 months. For a given year, Model R is an appropriate model if the group's predicted score at the end of the year is at least 1 point lower than the group's predicted score at the end of the previous year. Based on this information, for how many years is R an appropriate model? And we need to give a reason for that. So part C. Let's find, we know R, we can find R of 12, right? R of 12. I have R stored in for Y1. So R of 12 is Y1 at 12. 67.303. So at the end of 1 year, that's their score. At the end of the next year, the question is it at least 1 point lower? At least 1 point lower. If it is, then R is still valid. So let's find out. 65.340. Is that at least 1 point lower? Yes. Let's go to the next year. 36 months. 64.164. Ooh, it's getting closer. Is it at least 1 point lower? Yes, it is. It's still at least 1 point lower. Okay, let's go to 48 months, 4 years. 63.321. Is it at least 1 point lower than the end of the third year? No, it is not. So R is valid for 3 years. Since R of 36 minus R of 48 is less than 1. That's what I would say, because we had to give a reason for our answer. Okay. Part C was a little tough. The last part of B was a little tough. But I really thought the rest of it was good. And that's, if you can get 4 out of the 6 points, you're doing really well. Okay? Let's take a look at another example here. Michael mows lawns as a summer job, earning $1,520, which he deposits into a savings account that earns interest. After 5 months, the amount in the account has risen to this amount. After 12 months, the amount is this amount. The amount of money that Michael has can be modeled by M here. Here's our function, where M is the amount in dollars, think of money, at time T months, since the 1520 was deposited into the account. Part A. Use the given data to write 2 equations that can be used to find A and B, and then find A and B. We can do this. Okay, I have actually been given 3 sets of data. Time 0, time 5, and time 12. I have all 3 sets of data. Okay? I'm only going to need 2 sets of data to write these 2 equations. 2 unknowns, 2 equations, right? So I'm going to use the 2 easiest I have, and that is time 0 and time 5. We could use the other 2, but it would make life more difficult. If we use these 2, it would make it a more difficult computation. Time 0 is always a good thing. So if they are kind enough to give you a time 0, use time 0. Okay, so here's my equation. I'm going to begin by putting 0 in for t. So A times B to the 0 over 12 is equal to our original amount of 1520. A times B to the 5 over 12 is going to equal 1526.31. Those are my 2 equations that can be used to find A and B. So I've earned a point just for writing that down. Part 2 of Part A is to find A and B. I'm going to start with my first one because that's going to have an exponent of 0. B to the 0 is 1. So A is equal to 1520. Now I'm going to put 1520 in for that B, and for that A, I mean. So 1520 B to the 5/12 is equal to 1526.31. Divide both sides by 1520. And now we're going to raise both sides to the 12/5, right? And we'll get that decimal. Okay, 1526.31 divided by 1520, all to the 12 over 5. So that is 1.00999. Okay? You must give at least 3 values after the decimal point. I'm going to store that number in for B, and I think I'm going to go ahead and I'm going to put my equation in for Y1. So it was 1520 times B to the t over 12, x over 12. There's my function. Okay? Since b is bigger than 1, we're looking at a growth situation, right? It's a growth situation. Part B. I feel like changing up my color here. Go to a blue. All right. Part B. Use the given data to find the average rate of change of the amount of money in the account from time 5 to time 12 months. Express your answer as a decimal. Show the computations that lead to your answer. Average rate of change, delta M over delta T, yeah? From 5 to 12. So M at 12 minus M at 5 over 12 minus 5. M of 12 was 1535.2. M of 5 is 1526.31. This is part 1 of part B. Okay. To our calculator we go. And I'm going to put parentheses around my numerator, but if you prefer, you can use the fraction template. Oops. My mind was thinking 7 there. And we get 1.27. So the average rate of change is 1.27. Okay. Since T is in months, that means on average, the student is earning, Michael is earning $1.27 per month on average. Okay. Over that time interval, from 5 to 12 months. Okay, so we did part 1 of part B. Now part 2. Use M of 12 and the average rate of change found in part 1 of part B to estimate the amount of money Michael has in the account at 24 months. Here's where we're using the average rate of change to approximate another value. So, in my mind, when I see that, I'm thinking y minus y1 is the slope times x minus x1. That's what I'm thinking, okay? Where m is the rate that we just found, okay? X's are the times, yeah? So we want time 24, and they tell me to use time 12. These are our amounts. This is going to be the amount at time 24. This needs to be the amount at time 12. Okay? So, and this is just an approximation. So I'm not going to use equal signs. I'm going to use approximately equal signs. So M at 24 minus M at 12 is approximately equal to that average rate of change times 24 minus 12. M of 12, that is our 1535.2. So this is going to be M of 24. I'm going to move that over and replace it with 1535.20 if you like, plus 1.27 times 12. So M of 24 is approximately equal to 1535.2 plus 1.27 times 12. 1550.44. Okay? Alright, part 2 of part B is done. Now let's go to part 3. Let E of T be the estimate of the amount of money in dollars that Michael has in the account at time T months using the average rate of change found in part 1. Okay? E of 24 was determined in part 2. So that's what we found in part 2. That was our estimate. If E of T is used to estimate values of M for time greater than 12, like we did in part 2, does the error in the estimate increase or decrease as time increases? Remember, expect this one to be looking at the graph of your function. Expect that. Okay? What does the graph of this exponential function look like? Huh? Well, we have it stored in here. Shall we take a look at the graph? Let's go. We want to go beyond 12 months, right? And I think I might go beyond the 2 years because we found M of 20. Well, we approximated M of 24. I think, well, you know what? Let's just go to 24. The lowest amount that could possibly be is the amount that he started with. And then supposedly we're going to, well, I don't know, how far are we going? We got an approximation of 1550 down here. Maybe I'll go to 1600. Okay. Now that's hard to see, isn't it? Isn't that hard to see? Okay, I shouldn't have gone to 1600. Maybe I'll go to, 1550? It is really difficult to tell that this is exponential, isn't it? Why is it difficult to tell that that's exponential? Well, it is exponential, but look at the value of B. Look how close it is to 1. So even though it's hard to see, what is the concavity of this? It is concave up because B is bigger than 1. It's concave up. The curve is concave up. Oops, sorry, off the screen. The curve is concave up, and we used a secant line, didn't we? We used a secant line. And we are using the secant line to approximate values after this point. What's going to happen to the error in the actual? There's the actual. There's the approximation. What's going to be happening to the error as time goes on? Well, the error is going to be getting bigger. The error increases. That's the answer, but they tell us to explain a reason. Since M of T is increasing and concave up. Concave up. And the secant line, this is called a secant line that goes through 2 points. The secant line is below the curve and getting further from the curve. Good enough. Harder part. That's always a harder part. But it's going to deal, you know it's going to deal with the shape of the graph. Part C. Michael closes the account when the amount reaches 1600. Essentially, we need to find the time that that happens. because we want the domain. So we want the range of, we want the time values. So if he closes it at 1600, we need to find out when does this thing reach 1600. When does it reach 1600? Well, 1600 is above this graph, so I need to go to my window. I need to make sure I include 1600, right? So I'm going to go to maybe 1610. There's the curve. There's 1600. Boy, I need to go much further than, I need to increase it past 24. Maybe 4 years, you think? Oops. What did I do? Quit. Oh, 0, maybe 48 months. Will that work? Is that enough? No, I need to go past 48 months. Maybe to 80 months. This is going to do it. Okay, second calc 5, enter, enter, enter. There's the time in months. So what is the domain? The domain is starting at 0 and going to 61.907. At least 3 values after the decimal point is what you need to show. Okay. And I will tell you something, you guys. I'm getting a slightly different answer for that than what I had the first time I did this problem. So I may have typed something in slightly wrong, but I don't know if the error is here or there. But I do know that my process is right. So even if I made a slightly wrong error, the one that I got on my other sheet, you guys, I got 61.8592. So it's close, but definitely not within the, I mean, your answer has to be correct to 3 decimal places. So I'm not going to stress about this because I know that my process was right. But there is a chance I made a slight error somewhere. Did I store B right? Now I'm really curious if I stored B right. B, that. Oh, that is the difference. Oh, I did something wrong. Oh. Oh, I know exactly what I did wrong. Okay. The problem is not with this one, it's with what my other one is. So I'll go change my other one. Okay, good to know. Alrighty, that's it. That's it for FRQs for modeling a non-periodic context.